Hello, my name is John Gabriel, and now we are doing the Energy Grand Challenge on how to make solar panels economical. Essentially, the background of the project is um, the sun's contribution to human energy needs is substantial. Worldwide solar electricity generation is growing and is a multi-billion-dollar industry. However, our reliance on non-renewable sources such as coal and natural gas prevent our transition to solar and renewable energy uh, to decrease in time, basically. So what we're doing is we need to solve this problem by making solar panels more economical, as they are very expensive at this point. We have made advances in the decrease in price for solar cells. However, they are not as economically competitive as at this point. So what we did for our project was we analyzed raw data from New York State, county by county, um, to create a program that essentially allows the user to interact and get to know um, what it is they need to know. So, like for example, if they're a solar user, it presents facts and figures about their switch to solar, how much money they've saved, and how their cost compares to other counties, and how much essentially gives the economic facts that improve upon their decision to switch to solar. If they haven't switched to solar, it convinces the user to switch by giving them the basic economics and facts and figures. The long term for our program is for users in New York State and maybe even around the United States to use a program such as this to make a decision to switch to solar, therefore increasing the demand, therefore increasing the price and decreasing the supply. Decreases supply, decreases the price in solar. Basic economics. So this is our algorithm. Um, Essentially what it is. So the square is the user input, the circle is calculations, and the triangle is the display. Uh, so it starts by asking what county the user lives in. Then it validates the data from the user input to verify that the user hasn't inputted anything invalid. Essentially after this, it'll ask the main question, which is, do you use solar energy to power your home? From here, it branches out, yes or no. If it goes yes, it asks you for the total cost of solar panels, validates your data, asks for your amount received for subsidy credit, validates your data again, and average kilowatt hours used per month, it validates the data. It essentially keeps going, asks if we break even, years passed, and then it displays a series of facts and figures. So, for example, test case 1, if you use solar panels, asks you for all of this, then it outputs your county that you picked, average kilowatt hours per year, cost per year, average amount of incentives in their county, average project cost, gives the max and min of the county, then asks if you broke even on solar panels, then it essentially gives the average capacity factor, incentive data, total amount of money you saved so far, and asks if you wanted to run again. The second part of the code is if they don't break even on solar panels. Actually, no. If they haven't used solar energy to power their home. If they haven't, it'll output the total electric cost for the whole year. Then, if they do want to learn how to save more money, helps pinpoint when they will break even on solar panels. So for in this case, 1.8 years at an average of 174.8 cents per year. code was set up like this mostly due to the fact that, if they don't use solar, then it branches out. If they do use solar, it does branch out. It's very efficient in its structure and allows for greater usability and user friendliness. So this is the demonstration of our code. Essentially, we run the code, and it first asks what county do you live in. This is a limitation of our code. Since there's so many counties in New York, we can't simply create a menu for all the counties. There'll be way too many outputs. So we just ask the users to look in the CSV file, and then it asks, do you already use solar energy to power your home? We click yes, and it will ask us a bunch of questions. First is the input costs. So let's say $15,000 to first buy your first project. Subsidy cost from the government was $2,500. Average kilowatt hours is 650 hours. Then it asks you, have you broke even? Tell them yes. Then let's say you broke even 4 years. Then outputs a bunch of different facts and figures. So let's analyze what it does. It outputs what county you picked. So you picked Albany. Average kilowatt hours cost per year. So this is the number, how much it costs per kilowatt hour with solar the first time you don't break even in the county of Albany. This is the average, and this is the max in Albany, and this is the min in Albany. Then the average capacity factor is input in Albany County. Incentive data is also outputted. So in this case, you receive $10,000 less on average for the incentives compared to the Albany County of $13,000, and the total money you saved so far. You run the code again, and let's say this time we pick Orange County. Right? He said, let's say yes, and then let's say it was a big project. It was $50,000. Let's say you got a $20,000 subsidy credit from the government, and it's a big factory, so you use 1,500 kilowatt hours per month. Say you haven't broken even, then it will output how much incentives you increase. So let's say this makes sense because you received a $20,000 incentive, therefore you received higher than the state average, and it'll output how much average cost you paid. Alright, so our code also demonstrates data validation. Let's say you don't input anything into this county, it'll just keep asking until you input something. So Broom, do you use solar energy? Let's say you pick no. It will give you an error since you didn't pick anything. Say you live in Orange County, let's say no. Say you have 600 hours a month, and this time you want to learn how much money you could save. It will output a graph showing when you'll break even, your yearly cost. It'll tell you when you're how long it'll take you to break even, and how much you'll save each year after you break even. Let's say run the program again. Say Broom, right? Say no, and say 600. But this time you don't want to learn. Well, then it'll just give you an error because you have to learn. That's the point of the program. It's also data validation on if you do use solar energy. So let's say your total input cost is -900. It'll keep asking you because it's negative. No one can have a negative input cost. Say 6,000, -999. it'll keep asking you. And you put 0, that's fine, because there's no subsidy credit. Average number of kilowatt hours, negative. There it is again. So, there you have it. There is our code. So our program has uses outside of its function. So if an engineering professional wants to use this program, they can essentially use it to convince the general population in maybe New York or in the United States to switch to solar by providing them facts and information. However, it's very limited in its use, as the GUI is non-existent essentially, besides the menu, as well as the data that's presented. There needs to be more data to basically make a good case to the person who is going to switch to solar. However, an engineering professional can definitely use this in the future if it's expanded to its further use and to the future use that I have outlined in my program. Thank you for watching my project, and you have a great day.